I hope in this workshop you'll get a little more hands-on with Azure pipelines and you'll see how actually powerful it is. Azure Artifacts. So Artifacts is actually not an artifact storage, but what it does, it proxies all of other artifact repositories, and you can have all of those artifacts in one place. It just aggregates from public repositories and internal teams, everything in one place. And then we have Azure Test Plans. So when you actually deploy something in production or let's say staging environment, you can have automated tests, and it will say if you have some kind of performance degradation with some kind of browser, or let's say you deploy some kind of new code, and you can see that on certain browser you have some performance degradation, because with Azure Test Plans you can actually run tests on various browsers and platforms. So actually Azure Boards, Azure Repos, Azure Pipelines, Azure Artifacts, and Azure Test Plans, but at least 3 of those products are kind of similar to what is already in the market from another Microsoft offerings called GitHub, right? So Azure Boards is kind of similar with GitHub Issues. So what's the main difference between GitHub Issues and Azure Boards? So Azure Boards can also integrate with GitHub Issues, but what it does, additionally, you can do delivery plans, you can do powerful querying and reporting. So if you have some kind of PMO that does the reportings and so on, so Azure Boards has that capability, while GitHub Issues does not. So Azure Repos and GitHub Code, so that's another similar products from Microsoft. On the GitHub side, you already know the main GitHub offering. With Azure Repos, you have additionally integration with Active Directory. You can have, let's say, larger repos, and you can always migrate between Azure Repos and GitHub Code. But the main additional difference with Azure Repos is that you can, if you have some kind of enterprise, you can always integrate with Active Directory, and you don't need for your users to have create additional separate accounts, as it will be integrated. And then finally, GitHub Actions is very similar with Azure Pipelines. So what's the difference between GitHub Actions and Azure Pipelines? So the main difference is that Azure Pipelines has unlimited number of concurrent jobs, and with Azure Pipelines you can build your code on Linux, Windows, or even Macs, and you can always run agents on your self-hosted hardware, where GitHub Actions only supports Linux. And actually, you'll see later on that it has really rich deployment approvals, really rich UI, and it's easy to build everything in there. So, about the Azure pipelines. Let's talk about the key concepts of the Azure pipelines. So Azure pipelines always consists of the trigger. So you have to trigger your deployments. Let it be pull requests, let it be manual triggering or something else. And every pipeline consists of stages. Then every stage has its own agent, and this agent runs jobs. So agent can be, let's say, Linux agent, can be Windows agent, can be a Mac OS agent, and you can, let's say, in one stage run 3 concurrent jobs on different platforms and build your code down there. And you can always define dependencies of the jobs in the stage. Every job can have steps, and each step can be, let's say, some kind of script, some kind of task. Let's say task to publish artifact, to deploy your function, to, let's say, invoke some kind of API, and so on. So that's the main concept of Azure pipelines. So I think so it's kind of similar throughout the whole industry, so quite easy to understand. So then there's Azure Pipelines actually has 2 editor modes. Then there's classic editor, and you can configure your pipelines with the YAML files. So with YAML, they're only supported Azure repos, Git, then GitHub and Bitbucket Cloud, while Classic Editor supports a bit more repositories, but actually those are more deprecated ones. And probably one of the main things about the Azure pipelines that it has lots and lots of extensions. As you can see here in the screenshot, there's like over 1,300 of extensions. And on the right-hand side, you can see the example what you can do with some of them. Let's say with Terraform, you don't need to configure anything by hand to run your scripts about the Terraforms. You can always use just extension and define what you need. Same with AWS, Lambda functions deploy, just say what you need and it will be deployed, and you don't need to manage everything with custom scripts like, let's say, in GitHub Action, right? Azure pipelines releases. So releases are one of the main functions in Azure pipelines. And with releases, you can define your release. And with that release, you can, let's say, you have some kind of pipeline job to build code, and you can define where to deploy your code. You can deploy in dev environment, in staging environment, in production, and you can define stages, and one stage, several jobs. You can, let's say, do all the deployments in automated fashion, or you can put some gatings like approvals from certain persons. So your deployment will be paused until someone will approve your deployment, or you can have some kind of API that actually checks, let's say, deployment hours, and deployment will actually call that API, and API returns if you can deploy, if it's in deployment hours, and so on. So yeah, so lots of things you can do there. And okay, so that's the theory. So now let's dig deeper into the hands-on experience. So I'll copy paste our hands-on link to you. So what you'll need to do is open this link and accept the assignment. And once you accept the assignment, you can refresh the page and you'll see the link where you have forked your assignment. Let me just increase my window. Yeah. So all of you should have your own repository with hands-on assignment. What I'd like you to do is clone the repository. So if you have the GitHub account, you can clone, if you have added your keys to your GitHub account, you can clone the repository with SSH. For someone who doesn't have their keys added to GitHub, you have to clone your repository with HTTPS, but one thing before that is that you have to create your personal access token in GitHub. So to do so, you have to visit this link, hit generate new token, and select scopes and just generate new token. And I'll show you quickly how to do that. So just navigate to developer settings, personal access tokens, generate new one. Yeah, just note scaling trainings. Let's say for 7 days, just select scope repo and generate token, and copy your token somewhere and keep it safe because you'll have to reuse them. Okay. So this is just for those who doesn't have keys added to GitHub. Cool. Okay, so for other ones, let's just clone the repository. Let me open my terminal. Okay, let me just make it a bit brighter. Yeah, I hope so. My terminal is readable. Can somebody confirm?
Yes, we can hear.
Cool, thank you. Okay, let's clone the repo and let's change directory to that repo. And let's have it in place. Okay, cool. So let's have a quick overview of the repo. So in this repository, we have 3 assignments. So first of all, we'll start with building Docker container and linting Docker image. Then we'll deploy Azure. We'll deploy Lambda function to AWS. And lastly, but not least, we'll deploy Azure function to Microsoft Azure Cloud. Okay, so let's start with the Docker. And first of all, I'd like you to check if to log into Azure DevOps. Here's the link. Here's the link. So let's continue. A quick overview of the Azure DevOps. So you can see here that currently your project is empty. As I told you before, there is Azure boards where you can check your Kanban board and link to your GitHub issues and so on. Then you have some kind of queries where your project manager can run queries and get some data what he needs. You can create and schedule your sprints with that Kanban board, so everything is actually in one place with Azure repos as well. You can you can set up your own code repository here. 10 Azure pipelines with which we're going to work on today. Test plans, you can set up your test plans, and here's some videos and everything how it works, but today we're not going to touch that. And artifacts, again, as I mentioned before, all of your artifact feeds are in one place for you to easier get a picture of what artifacts your team is using from which places, and it's really convenient. Right, so talking about the pipelines, we can create a new pipeline. We have environments to see what we have done earlier. Releases, we're going to talk about releases a bit later. Then we have library. So library is actually our variables and secure variables, where we can define variables to use between all of our pipelines, or we can add environment variables, let's say only for the certain pipelines. And we have task groups where we can manage our common builds. And deployment groups where we can create, let's say, deployment pools, let's say production public cloud, production on premises, development private cloud somewhere, and we can define all of those pools here, Kubernetes clusters, and so on. Right, so let's get started with pipelines. So first of all, what we need to do is just hit create a pipeline. So we're going to actually, you see here, use the classic editor to create pipeline without YAML, but we'll build this pipeline with YAML. So it asks you when you're creating your pipeline, where is your code? So in this case, we want to show you how Azure DevOps pipelines actually integrates with all of the other systems. So you can see that it's really flexible. So in this case, let's connect to our GitHub repository. And I'll need you to select the repository which you have created in previous step. And granted access, approve and install. Right. Select your DevOps organization. Switch directory. Yeah, and now for the sake of this case, so let's select the Docker pipeline, which actually defines our pipeline. So let's select build and push an image to Azure Container Registry. Right. It will ask you to load subscriptions and select the subscription. Select a container registry called Skaylink 1 and your image name. So you can just define your surname, let's see, name and surname. And Docker file, leave it as it is, as actually Azure Pipelines automatically scanned our repository and it find that we have Docker file inside our Docker directory. And then hit validate and configure. Right, so we have created our, actually Azure has created pipeline YAML for us, and let's get a quick overview of it. So in here we see the trigger on main. It means that when we push changes to main branch, this will trigger our pipeline. So push to main, or actually after pull request has been merged to main branch, will trigger this deployment. Right, this is self-explanatory. So we have defined variables for this pipeline. So we can see what it did. It automatically created service connection to our created Azure Container Registry. It automatically found our Docker file path. So it's /docker file. So if I'll go back to our repository, we have Docker directory. And in Docker directory, we have a Docker file, which actually builds our Golang application. And yeah, it builds our Golang application. Right, then what we see is that we're defining our container tag and on which agent we're running this build. So in this case, we're running on Ubuntu Linux machine. As I mentioned before, you can always run your pipelines on Windows or Mac OS or Linux machines. Just need to define agents images name. And then, as I mentioned before, in pipelines, everything is your jobs actually defined in stages, and each stage has its own jobs, and each job has its own steps, right? We have stages. So we have one stage that has build job running on our Ubuntu machine pool, and our job has actually steps, which has actually one task. And this task is actually to build and push an image to a container registry. And you can see this task is actually Docker V2 extension in Azure Pipelines. And you can see there's even a settings button which you click, and you can see a nice integration window where you can do some custom modifications. Yep, and we can click save our pipeline. And we can, let's say, rename our pipeline. Rename to Docker build. Yep. There's my repository. Let me check. Okay. Yeah, and you can see what the what actually Azure DevOps did pipelines. It actually created a Azure Pipelines YAML in my repository, and you can see the YAML that we have built for it in our source code repository. Okay, so let's hit the run button. And here we can see our current job status and our stages here. So we have nice logging in pipelines. You see that it actually checks out the code, builds a Docker image, and we can see that our actually container has been built and pushed to Docker registry. Okay, so previous step, I have run the pipeline, so now we can check that our container has been actually pushed to the repository. So yeah, you see that actually my container has been pushed to Azure repository and it's been there. So to continue, so everything on pull request or when pull request has been merged or any pushes to master branch, our pipeline will be executed and will build a Docker image for our Go application. So for the next part, let's create a new pipeline, actually. Oops, sorry. Yeah, so let's create a new pipeline. Again, let's connect our GitHub repository. And And this time, let's select starter pipeline. And yeah, and now what we would like to do is actually to build a Docker lint step and go code tests for our application on pull request. So when somebody raises a pull request for our application, we want to run some checks and to see if we can actually match the new code. So for this case, the trigger should be set to none. And then there is, right. And then we define that on pull requests that actually in domain want to mention the main branch is triggered and paths include Docker. So actually what it means is that where is our repository? So we're actually including only Docker paths. So if we have, let's say, some kind of mono repo with different services in one repository, so what we're telling Azure Pipelines is that we're actually looking only into the Docker directory. And if there are some other code changes in other directories, so this pipeline will not kick in. It will kick in only if changes are being happen in Docker path. Right, so, and let's have some steps. So we can always use the steps assistant. So in this case, we want to test our Golang application, first of all, before building the Docker container. So yeah. So let's provide command test, and let's have without any arguments, just working directory is our Docker application. Okay, so we have created a task under the steps to actually test our Golang application. Now, what else we want to do is we'd like to lint our Docker file if there are no issues in Docker file. So in this case, let's use the command line. And in command line, let's run the command docker run hado lint and lint our Docker file. If I'm too fast or something, just let me know, but all of the code is actually in your repository. So if you go to your repository, hit Docker, and everything that we're doing is actually in the README file. Okay, so again, let's probably rename that this Azure Pipelines kicks in actually after the pull request, so we can rename the Azure Pipelines file accordingly. And let's hit save and run. This will create Azure Pipelines PR YAML in your repository. So let's just commit directly to the main branch. Let's hit save and run. Okay, it's creating pipeline. And as you could see in our repository, there's now two YAML files. One is the Azure pipeline, which actually builds the Docker image and pushes it to registry, and another one is on pull requests to have lints. Yeah, someone is actually deleting pipelines. Please don't do this. So I'll just rename this pipeline to, let's say, Docker lint. This one, Docker build, yeah, to have more clarity. Okay, so now let's test our pipeline if our pipeline is working correctly. So let's do some code changes in our application. So if you go to main Go application and we edit the file and let's say change version to 0.2 in our web application, and let's create a new branch and let's say, yeah, that's good. Let's say we create a pull request that we have where we have changed our application version, and we should see that actually our pipeline has been kicked in. Yeah, too many pipelines because okay, so Docker lint should kick in, and let's see. Right, I have created actually too many pipelines, so I can delete some of those. Right, okay, 2 pipelines at the moment. And we actually can check the current build, what's happening. I think so. I have throttled something with our previous pipeline, something this on this already. So oh, okay, so actually I made a mistake because on pull request it's building Docker image, so let's add the pull request trigger none. So on pull request this job won't be kicked in, right? Okay, so now we see that our linting job has been kicked in, and what it does, it first of all runs Go tests. Tests for our Go application. And we actually see that it has failed. So why it has failed? Because in our code application, we actually bumped the version to 0.2, but our tests actually expecting 0.1. And if we'll go to our pull request, we see that we have a failed job in our pull request and checks were not successful. So let's fix this. Let's change to our branch and let's update our tests to expect 0.2. And let's commit to our branch. Okay, so we actually committed to our branch and our tests. We see that Docker lint has been queued again and again running. And our fix should go all green now. Yes, now we can see that our Go tests has been passed successfully. And actually, our Docker file linting utility Hadolint has been also passed successfully. So now it means that in our pull request, everything is green, and we can actually merge our pull request. And after merging pull request, our Docker build pipeline kicks in, and it starts building our Docker image. And we can see that our build has finished successfully, and our Docker image is actually available in Docker registry. So that's it with the first part. Some of you may have unable to configure a service on the selected GitHub repository. This is likely caused by not having the necessary permissions to manage hooks for the selected repository. So when you actually have created a new pipeline and connected with GitHub, I think so the issue was that you had to authorize GitHub with your repository and apply permissions. Let's say if I select, I'll go to pipelines, and if I create a new pipeline, let's say GitHub, but I select in this time, yeah, you see, when this window pops up, you can authorize pipelines, and let's say I select another repository. There were permissions to read and checks codes and everything. You have to select your repository here, so make sure that when you're selecting your repository, it's here for you to approve and install. The second part is actually a totally different one. So if you haven't finished the first part, you can jump into the second part of our trainings, and yeah, and let's do it together again. So now what I would like you to do is let's continue with AWS part. And for that, we'll have to export some environment variables. So if you're using Linux or Mac OS, this is the command for you to use. In a moment, I'll paste you the access keys and secret keys to AWS. But if you're using Windows, I strongly encourage you to use Ubuntu Shell. If you cannot use Ubuntu Shell, then use PowerShell, and with PowerShell, the syntax to set environment variables is as defined. And let me just share a AWS access and secret keys to the chat. Okay, so you should be able to set your AWS credentials. So yeah, just like so. And with command line utility, now what we'll need to do is to create our own environment with Terraform. So what we need to do is we have our repository cloned on our laptops locally. So let's change directory to AWS and run command terraform init. Those of you who are running Windows, you should provide full path to your Terraform CLI, like c/terraform.exe and run terraform init command. What it will do, it will install AWS dependencies, so you can create resources on AWS cloud. Okay, and after terraform init command, let's run terraform plan. And if you have set your environment variables correctly, it will show you that our Terraform actually plans to add 5 resources. Okay, so if there are no issues at the moment,
which command? Terraform?
After Terraform init, run Terraform plan.
Plan, okay.
Those should be actually 3 environment variables, so AWS access key ID, AWS secret access key, and AWS default region EU central one. Okay, so I assume nobody else has issues after Terraform plan, so just hit now Terraform apply. It will provide the same output as Terraform plan, but instead it will ask you to enter a value if you want to perform those actions, and just enter yes and hit enter. And wait for the Terraform to actually create some AWS resources, so you would be able to deploy your serverless Lambda function to AWS via Azure pipelines. Cool. So what it did, it actually set up AWS Lambda resource for me, which has function name Azure Pipelines Thankful Primate. For you, it would have different names, so everyone will have a unique name. Okay, so again, what we've done, we've created a Azure Pipelines function with our Terraform script. So what we're going to do is actually we have our again Golang application which receives in JSON name value, and it will output your name. Just it will say hello, your name, and to do that, let's create a new pipeline. Again, that's our pipelines. Let's create a new pipeline. Let's select our GitHub repository. Again, let's select the same GitHub repository that everyone has worked. And let's select starter pipeline. Okay. So first things first, what we're going to do, let's create our Azure Pipelines YAML file in, let's say, AWS directory. Let's have it down there. And now let's build the pipeline all together. So first, by the way, so the code that you can copy paste is here in the README file of your in your repository. You have the AWS directory, and in the README file you have your code which you can just copy paste. Okay. Okay, so let's walk through this. So again, let's build this build only on changes into the main branch, and paths include only AWS. Means that our code changes only in AWS directory will trigger this job. Then we don't actually want to deploy our Lambda function on pull requests, right? And then let's copy paste our stages. Right, so let's walk you through it. Stages, so build code. So again, we're using the Go extension, which actually builds our code in AWS directory. Then we're using the archive files directory extension, which actually zips our code. So our main.go application will be zipped, and as zip file is being uploaded to AWS Lambda function, and it actually only accepts zip files. Then, as we're going to do this a multi-stage build, so our stages are going to be built, and then we're going to have a deploy stage. We need to publish artifact, because artifacts are not being shared between the builds by default, and that actually makes perfect sense, because all of your jobs in stages, so different jobs are running on different agents. So let's say this build job is running on Ubuntu Latest, and another build or deployment job will be running on different agents. So these agents between themselves are not actually sharing by default your artifacts that you have produced by pipelines. So in this case, we have to publish our pipeline artifact. And what we're doing, we're using the environment built-in environment variable to have our file zipped. Artifact name, we're providing Lambda build, and publish location just pipeline. As you can see here, everything in our extension window. And if you have any questions, or you can always, let's say, hit the info button and get more information about each field. Okay, and now let's add a deploy stage. Yep. So our deploy stage, again, first of all, what it does, it actually should download our pipeline artifact, so the one that we have published before. And yeah, as I told you before, AWS has lots of extensions, and in this case, we're using AWS Lambda deploy function extension. And what we'll do, we'll deploy our function name to AWS. So what we'll need to change in this case is we have our function name, so we have to copy paste our function name and put it into the function name placeholder here. Okay. And then you can see
single quote, right?
Yeah.
Function name. Okay.
Yeah, I mean, if you're always struggling, you can hit settings. You can insert your function name and hit add, and it will update your YAML file. So in this case, if let's say I put it in double quotes or something like this, probably this is wrong. So I can hit settings. I can put it however I like. I can hit add, and it will fix it for me. Okay. So this is actually quite nice. Now we have to deploy our Lambda function, but how actually does it get our AWS access keys and access key ID? See, here we're providing them as environment variables. So in Azure pipelines, you can also define your variables. So if you hit the variables and hit new variable, right? So let's provide AWS access key name. Let's keep this value secret, as it's actually secret for us. And as we have defined our access key and secret access keys before, let's paste the access key ID value that we have used it before. click OK, and add another environment variable, secret access key. Keep the value secret. Yeah, if you want me, I can paste those values again into the chat. For you to make it easier.
It's the same we used in defining.
Yeah, those are the same. And let's add one more environment variable is AWS region. I think so. AWS region. Let me double check on that. Yes, it's AWS region, and this value is actually not secret, so just define EU central. Okay. AWS region, central one, and this is again not a secret environment variable. So we can see that this pipeline actually has 3 variables. One is not secret and 2 are secrets, and at this moment you know how to pass some secrets via Azure pipeline, and we can just save this. And from now on, our Lambda deploy function will know how to access our AWS resources. Okay. So now let's just save and run, commit to the main branch for demo purposes. And as our build is multi-stage, now you can see that our pipeline has 2 stages, right?
When I see a summary, I should be able to see the actual build.
Yes. So you can see that our build code stage actually produced one artifact that we have published. It's Lambda build. You can see the size and our build ID file name. And our step is deploy code. Okay. And it's in the queue at the moment. So in the meantime, let's rename our pipeline to have it more meaning. Say AWS Lambda. Okay, still in queue. Okay, so deploy code is in progress, and we can see that it's actually downloading our artifact and deploying Lambda function. Okay, so it's actually deployed, but from our build, we don't see if it's actually successful. If it actually has been successfully deployed, right? Okay, so let's add test stage to our pipeline to actually check if our Lambda function has been deployed. So let's add another stage which is called test, and now it should have the Lambda invoke task. Yep. Again, we're using AWS extension.
Sorry, can you repeat how to get to this AWS Lambda YAML file?
Yes. Again, all of those files are in the repository. So if you just scroll down, you see that at the final stage to test our deployed code is working. So
okay.
Just that one.
Okay. But when I see pipelines, I should go immediately to pipeline and edit it?
Yes, edit your pipeline. Just okay. Again, you need to change your function name. Where is my function name that I have deployed? Okay. So our test stage and Lambda invoke function, I have to change my function name. And let's say I'll have to provide payload with my own name. Okay. Oops. So function name, my name. Let's hit the add button. And what it will do, it will actually invoke my Lambda function. And it will get some kind of response. And then I have another task with actually with script that will actually echo the response that I will get from my Lambda function. So if we remember previously, we have our main Go application that actually, if I provide my name, should say hello Edgars. Okay. So let's get back to our pipelines and hit save. Commit directly to main branch, so our pipeline will kick in. Yeah, you see that our build is now starting. And now we can see that it actually has 3 stages. You can easily, with Microsoft Azure DevOps pipelines, you can easily deploy your code to AWS, to Azure, to all of those different public clouds, and you don't need to write your own custom scripts because everything is actually extensible and you have lots of extensions to play around with. So as you can see, we can build code on public cloud, on Azure DevOps cloud. We can build code on premises or our own infrastructure. And in this case, we're deploying our code to AWS Lambda functions. And later on, I'll show you how to deploy code to Azure functions. So you can see that actually the Azure DevOps has lots of integrations, and it's actually true what they're stating, that you can run anything anywhere. So yeah, we see that our code has been deployed to AWS, and our tests should be running soon.
We are competing for agents.
Yeah, that's true. Yeah, and my tests are starting to run. And you can see that it starts invoking function AWS, and it has completed invocation of Lambda function. And it should run the command line to check what it has received, what response. Normally it takes a lot faster. And you got an error, right? When the test code failed. Okay, so let's see where your function name. Okay, so you haven't replaced your function name with function name, actually.
I added the variable, call it function name. It doesn't work.
Okay, so variables should be added. Okay, so if you go to variables and if you select your function name, right, it says how you should use your variables. Okay.
Okay, so instead of just $,
yeah, put it
$, and okay, function name. So okay, I will replace it and run again. Thanks.
Okay, and my tests completed successfully. So we see that our Lambda function actually said hello Edgaras because we have provided our name to Lambda function. Let's continue with deploying Azure functions. So again, everything's from the start again. Let's go on your command line. And go to Azure directory. And we should run Terraform init. So Terraform pulls all of the plugins needed to talk to Microsoft Azure. And then Terraform plan to see if right, so I missed the environment variables part, sorry for that. Let's go to Azure, and again I'll copy paste the environment variables to the chat for the Azure. Yeah, so in my case, as I'm using the shell, I'll export the environment variables for the shell command, but if you're using PowerShell, there's a command as well. And by running Terraform plan, we'll see if our environment variables are actually correct ones. So Terraform plan, any success for anyone?
I'm going to run Terraform plan. Good. 5 to add.
Cool. Okay. So run Terraform plan, Terraform apply, and confirm with yes. So this will actually prepare environment for the Azure function application. Okay, and at this time, you should get your unique Azure function URL, which you can visit actually. And right, and you see that your function 0.4 application is up and running, but that's only the environment that's running for our application. But we need to actually deploy one. So what we're going to do is actually we're going to deploy again a Golang application that actually receives a parameter name, and it will just reply with hello, your provided name, this is HTTP triggered function executed successful. Okay, so let's now deploy to our application to Azure Functions, and we'll see how Azure DevOps pipelines actually integrates with Azure providers. Okay, so let's create a new pipeline. Again, GitHub. Connect our repository. Select starter pipeline. And again, let's put this our Azure pipelines YAML file under the Azure directory to have it more nicely and clean. And again, by the way, just to repeat myself, all of the code that's being copy-pasted is actually provided in the README. So we have 1, 2, and 3 parts of the code that will be copy-pasted into our pipelines. Where's my pipeline? Yeah, new pipeline. Okay, so again, we want to trigger our pipeline only on changes made to the main branch. So that's either just push to the main branch, which is not recommended, or after merging the pull request. And we want this trigger to happen only to changes in Azure directory in our source code repository. But we actually don't want to run our triggers when the pull request has been raised. And now let's proceed with the build stage. Okay, so now we have build stage, same build stage that we used for deploying AWS Lambda function. So in this case, we're building our Go application, nothing new here. We're archiving the files. Again, we need to provide zip file to our Azure functions. And we're publishing the pipeline artifact because, again, because we cannot share files by default between our builds. So we have to publish artifact on one build and then download pipeline artifact on another stage. So let's add deployment stage, which actually same as for AWS was. First of all, we need to download our pipeline artifact, and we have artifact name, Lambda build, and so this one is quite new. So what we're doing, we're actually deploying Azure Functions application. So just we'll need to press on the settings, and we'll need to change Azure subscriptions to the one that we're using. So select from the service connections list, then select your application name. So first class support integration with between Azure DevOps pipeline and Azure functions, so you can select your application name from the drop-down list. So you should see one, or if you don't remember, check from Terraform output. Mine is Eager Mustang. So I select my application name, Eager Mustang. Pretty much that's it. You can just hit add, and we see that we have our task filled in. Just let me double check with the Azure subscription which one to use. Okay, should be okay. Right, so we have our deploy stage, and the last stage again is to test our function app if it's working. So let's have a third stage named invoke, and let's use Azure function extension. Again, if you want to find any extensions, you can just enter here Azure functions, and provide Azure function URL to invoke your Azure functions. So in this case, our Azure functions URL will be this one. So yeah, and /API/function. Okay, so I pasted in chat application keys for your function. So find your function name, and you'll see your application key, and enter that application key into the function key.
But this is the host key, or what way we are using? Host key. Okay.
Yeah.
Good.
And after that, query parameters, name functions. Again, I'll provide my own name, and I'll hit save and run. Again, commit directly to the main branch for demo purposes. Okay, I'll just rename my pipeline function to and we see that our Golang application is being built. Then our code package should be deployed to Azure Functions. Cool. So I'm still waiting for my code to be deployed. Yes, it's being deployed at the moment. And invoke actually failed. It's not saying why. Either way, if this step failed, we can always check if our application is running correctly. So just visit your function URL after you have deployed your function. then hit /API function, enter name parameter, and you can see that our function has been deployed successfully. And if I pass it through my name parameter, it says, hello Edgaras, this is HTTP trigger function that has been executed successfully. So yep. Or we can change it to world parameter, and we can see that it changes the hello stuff. Oh, okay, so I haven't changed my actual pipeline. Yeah. Still failing with YAMLs, right?
Copying again.
Yeah.
Get.
Usually you need to have some kind of rulers with YAML.
The problem that it has tabs. So if it's not on the right position,
yeah,
tabs are important.
Yes, those are the main problems with YAML files that everybody hates.
I heard many times our developers screaming.
Yeah. With the JSONs, there's commas. With YAML files, there's spaces. Okay, so while your pipelines are kicking off, I'll briefly show you the releases page. So what am I going to do is I'm going to edit my pipeline of Azure function, and I'm going to strip off the invoke stage as well as the deploy stage. So now I'll have my pipeline as a CI tool, continuous integration, which actually builds my code and publishes the pipeline artifact. But this pipeline will not do the deployments, as the deployments will be done by the Azure Pipelines releases service. So this is just a quick and briefly overview. You don't need to follow me for the releases, but I think so that's an interesting stuff you should also need to know about. Okay. So yeah, and okay. Right. So
should we follow you or just watch?
You can just watch, because I'll show you just briefly, and actually we're running a bit out of time.
Okay.
So in releases, you can choose any template we would like to deploy. Let's say deploy to Kubernetes cluster. Let's say deploy Node.js to Azure App Service. Deploy function app, as we're going to use this one. Deploy Go app to Azure App Service. Or just empty job to have and push your code however you like. So in this case, let's deploy a function app to Azure Functions. and have stage name, let's say just production, deploy to production, right? And we have one job, one task. So let's add artifact, and let's add artifact from our Azure function, as we're building our application for Azure down there. Okay, so we have artifacts, and we have our view stage tasks. Why it's not showing stage tasks? Okay. Tasks. Okay. So we can parameterize our application. So Azure subscription. Application type. Why it's not letting me to choose anything? Pipeline parameter. Okay, probably I don't have any rights to that one, strangely. Yeah. Okay, what if I'll add an empty job that has tasks for stage 2, and let's add Azure functions. Okay, there I have it. Right. Okay, so application type, app. Index, application name, bigger Mustang. Okay. Yeah, so we created to deploy Azure function on releases. So let's go to our pipeline. Let's rename the stage to actually production deployment, and let's delete that one as that one was not working. So we can have, let's say, several jobs for the stages. So if we go to the tasks, we can create another task, let's say, to run some kind of shell scripts and so on, and it's very manageable. So, but for the sake of this demo, let's have a simple stage just to deploy to production, and let's add a continuous deployment trigger. So when we enable this one, or on when our pipeline to build the Azure application will kick in, this will enable a continuous deployment trigger for our releases. Okay, and I should have saved it. Okay, so I have to create again. Okay, let's create an empty job quickly. Stage protection. Okay, let's add artifact from our Azure function. Let's add this. Okay, continuous deployment trigger. Let's enable this. Let's add task to deploy to Azure function. Add It will ask us for Azure subscriptions, application type, it's on Linux, application name, Eager Mustang, everything's fine here. Let's save it. Pipeline, okay, so we have our pipeline in place. So, what's wrong with it? Cannot see it. Stop. It says no. Okay, and we then just create a release. Releases. Okay, so let's trigger our Azure function. Let's hit run pipeline. Yeah, so now you can see that our Azure function has only a build, and we can see that it actually automatically triggered our release. So we can just create a release.
Release may include several pipelines, right?
Yes. Okay, I hit too many releases, but yeah, so where's the release? Let's check the first one. Oh, this one is manually triggered by me. Manually triggered. Yeah, so you can see that our release is actually triggered by Azure Functions. And you can see that it has artifacts and it should deploy to production, but at the moment it's being queued for. And you can see summary that it's being triggered automatically. Yeah. Okay, let's open this one. And you can trigger your pipelines manually. Your release, sorry. Yep. Okay, it gives me some kind of errors. Let's check out this one. Edit release. Edit both. Yeah, edit tasks. I think so. I have function app deploy. Your Mustang. Should be working anyway, but you've got the idea of how the releases are working. So you can have, let's say, multi-stages. You can also add some kind of, let's say, pre-deployment conditions, like rules. Why it's not giving me that? Oh, because it's deploying in progress. And you can see how it's deploying. You can check the logs. And you can see that our deployment actually succeeded. You can always redeploy, you can check logs. You can also edit your release and add, let's say, pre-deployment conditions. So you should, let's say, if you don't want to set up continuous deployment, you can add, let's say, approvers to the list. So this will take from your Active Directory some kind of people. Let's say I can set myself as an approver, but I do not recommend it. Then there are other conditions, let's say post-deployment approvals. That's pretty much it. So, and you can set the pre-deployment conditions, like after release or manual only. So you can set the gates, some kind of like invoke REST API, like I told you before. One good use case, like actually if you want to allow deployments only during the working hours, so you can have some kind of REST API and set up to allow deployments if it's in the correct, let's say, working hours or not, and based on the response of your REST API or even Azure function that you have deployed, it will either allow or not allow the deployments, and so on. And you can also set the queues and triggers after release or even schedules when it's allowed, so you don't need to put that into the gates. So that's a brief overview of the Azure Pipelines releases function. And I think so. I hope that you had a good hands-on experience with Azure Pipelines. So if you still have any questions, let me know, or just write in the chat, and we're done for now. And I think so that's it.
Thank you very much.
Thank you.